My servers used to drown me in noise, not the exciting kind of noise where something is clearly broken and you fix it. The boring kind where everything is technically fine, alerts are technically off, and your inbox has 200 lines of log output that you glance at and immediately close. And then one day something actually goes wrong, and you realize you stopped reading 3 weeks ago. So I changed the setup. I put a model in charge of writing the summaries, and I kept everything else exactly as dumb and deterministic as it was before. That decision, the line between what the model touches and what it does not, is the whole point of this video. The actual problem with monitoring, if you have ever tried to take server monitoring seriously, you know the drill. You set up something like Prometheus or just a log shipping pipeline, you get metrics and logs flowing somewhere central, and then you have a beautiful dashboard that nobody looks at. The alerts get noisy, you tune them, they get noisy again, you silence a few, and eventually you are in a state where the thing that would have caught the problem 6 months ago is turned off because it was crying wolf. The problem is not that monitoring tools are bad. It is that the output of monitoring is designed for machines, not humans. A page of log lines or wall of metric charts tells you everything and communicates nothing. You need someone or something to translate it into a sentence a human can act on. And you do not have that person sitting around reading logs all day. Most of the time, nobody reads them until the service is already down and you are trying to figure out what happened in the past. That is the wrong moment to be reading logs. You want to catch it before it gets there. What I am actually running. Let me be concrete about what I have. I run a handful of Linux servers, a couple doing web and proxy work, one that handles automation tasks, and a database host. They emit logs and metrics constantly. CPU, memory, disk I/O, network, application level stuff like request counts and error rates and job durations. None of this is exotic. It is just the normal output of a normal small operation, and the volume is low enough that it fits comfortably in a model context window. That matters. If you are running a 100-node Kubernetes cluster with terabytes of logs a day, this pattern does not transfer directly, but for a small fleet where the total log volume per cycle is a few hundred lines and the metric snapshot fits in a page, it works well. The first step is collection, and I want to be clear that there is nothing clever here. I have a small script that runs on a schedule. Every 30 minutes, it pulls the last cycle of system metrics from each host, grabs the recent log lines from the services I care about, and writes it all into a plain text file. No database, no fancy pipeline, just a text blob that represents what the last 30 minutes looked like across the fleet. I kept it simple on purpose. The collection script has no model in it at all. It is just data gathering. It connects to each host, pulls the numbers, and writes them down. The metrics I collect are the ones that have actually mattered in the past. CPU load, memory use, disk space and I/O rates, network throughput, and then application-specific things like job queue depth and error counts per service. I deliberately do not collect everything possible. I collect the things I would check by hand if I thought something was wrong, and nothing more than that. If the collection script breaks, I notice immediately because I stop getting summaries. That is the built-in health check. The script breaking is itself a signal, and it is a signal I can catch without any AI involved. The model writes the summary. Once the data is collected, I pass it to a model with a short prompt. The prompt asks it to do one specific thing. Read this block of logs and metrics from the last cycle and write a short plain language summary of what changed and what looks unusual. 3 to 5 sentences. Flag anything that looks like it is trending the wrong way. I am not asking it to diagnose the problem. I am not asking it to recommend a fix. I am not asking it to tell me whether to page someone. I am asking it to translate a wall of numbers and log lines into a sentence I can read in 10 seconds while I am making coffee. And it does that well. The output lands in my chat and I read it. It takes me about 15 seconds. That is the whole interaction. The firm line I will not cross. Here is the part that I think matters more than anything else in this setup. The model writes the summary. The model does not set thresholds. The model does not decide whether I get woken up at 2 a.m. The actual alerting logic, the thing that sends a page or fires a critical notification, is a completely separate system. It is dumb deterministic code. Disk above 90% alert. Memory sustained above 80% for 10 minutes, alert. Process not responding, alert. These rules live in a config file and they never touch a model. The model can tell me in a summary that disk is trending upward this week, but whether that triggers a page is decided by a number, not a sentence. I will not let a model make that call. Not because models are bad at reading trends, but because the system that wakes me up at 2 a.m. needs to be the kind of system I can understand completely, test completely, and trust completely. A model is none of those things in that role. You never let a model decide an outage. Why that line exists. I want to say more about why I drew that line, because it is tempting to just let the model do more. The model is already reading the data. It already knows if something looks wrong. Why not just let it fire the alert? The answer is reliability and auditability. When a deterministic threshold fires, I know exactly why. Disk is at 92%. I can see that number. I can decide whether the threshold was right. I can tune it. When a model fires, I have to trust that its interpretation of the data was correct, in the context window it had, with the prompt I wrote, on that particular run. That is a lot of surface area for a thing that wakes me up in the middle of the night. I want my alerting to be boring and predictable. I want my summaries to be smart and readable. Those are two different jobs, and they need to be done by two different tools. What it actually costs. So what has this system actually found that I would have missed? A few things worth naming. Once it flagged that a particular service was restarting more frequently than usual. Not enough to breach any threshold, but the restart count had been climbing slowly for 4 days. The summary said something like this: service has restarted 7 times in the past 2 days, which is higher than the previous week average. I went and looked. There was a memory leak that had been building gradually. The threshold was set for process down, not for elevated restarts, so nothing had paged me. The summary caught it early enough that I fixed it before the service actually fell over. Another time it noted that disk write latency on the database host had been higher than usual for the past few cycles. Not alarming, but different. It turned out a backup job had started running at the wrong time and was competing with production writes. Again, no threshold was breached, but the summary was readable enough that I noticed the pattern, the honest limits. I want to be straightforward about where this breaks. The model can miss things. If the log output happens to not surface the right signal in that 30-minute window, the summary will be clean and the problem will still be growing. It is not a replacement for proper monitoring. It is a layer on top of it that makes the output more readable for a human. The dumb thresholds are still doing the real safety work. The summary layer just makes my daily reading habit sustainable. The model also overflags sometimes. It will flag things like this metric is slightly higher than the previous cycle when the difference is noise. I have gotten used to reading those with a light touch. If the summary sounds tentative and nothing else is pointing the same direction, I usually let it go. There is also a subtler failure mode. If the same unusual thing happens every day for 2 weeks, the model starts treating it as normal and stops flagging it. I noticed this with a cleanup job that was running slowly every night. After about a week of slow runs, it stopped appearing in the summaries because the model had seen enough cycles to treat it as baseline. I only caught it because I happened to look at the raw numbers directly. That is a real gap in this pattern. The model does not know the difference between seasonal variation and the real trend, and it does not always know what normal used to look like. That judgment stays with me. Tuning the prompt matters. One thing that took me a few weeks to get right was the prompt itself. My first version asked the model to summarize the data and tell me what to do. The output was way too long and way too confident. It would write 4 paragraphs of analysis and end with a recommendation like consider investigating the network configuration. That is not what I want. What I want is 2 sentences that tell me whether anything looks different today compared to yesterday, and 1 sentence if something looks genuinely unusual. Once I tightened the prompt to specify length and tone, the output became actually useful. Short, direct, no false confidence. The model is much better when you tell it exactly how you want the answer shaped. How often I read it. I check the summary the same way I check a weather app. Once in the morning, once in the afternoon, and again if I am about to do something that might affect the service. It takes 15 seconds each time. That is it. I am not glued to a dashboard. I am not running queries, I am reading a sentence. On a normal day, the summary says something like, disk and memory are stable, no unusual log patterns, one service logged a higher than normal response time on 2 requests but recovered. I read that, I registered that everything is fine, and I closed the chat. On a bad day, the summary says something is different, and I have enough context to go look. The whole value of the system is that it reduces my daily monitoring to the cognitive load of a glance instead of a page of numbers. What this costs? The cost is genuinely small. I am running a summarization call every 30 minutes. Each call passes a few hundred lines of text and gets back 5 sentences. The token count per call is low. I am nowhere near the kind of volume that makes this expensive. Even running it around the clock, the model cost is a few dollars a month at most. The infrastructure cost is just the script running on one of the servers I already have. Nothing extra to provision, nothing extra to pay for. The only real cost was a few afternoons building and tuning the prompt and the collection script. And once that was done, it has been running without changes for months. I want to be clear that this is a paid model call. I am not going to tell you it is free. It is cheap, but it is not free. If you are building something similar, factor in the API cost for your call frequency and your data volume before you commit to the design. Run to this pattern fits. I want to be honest about who this makes sense for. If you are running a serious production service at scale, you already have SREs and proper observability tooling, and this is not the thing you are missing. If you are running a personal project on one server, the overhead probably is not worth it. The sweet spot is where I am. A few servers doing real work, no dedicated ops person, and a monitoring situation that is technically working but producing more noise than signal. If reading your monitoring output feels like a chore you keep skipping, a summary layer can make it a habit you actually do. That is the whole pitch. The thing I keep telling myself, I want to close with the frame that keeps me honest about this whole setup. The model is a translator, not a decision maker. It takes something that was designed for machines and makes it readable for a human. That is a real job and it does it well. But the decision of whether something is actually a problem, the decision of whether to wake me up, the decision of whether to roll back a deploy, those stay with me, not with the model. The model gives me better information. I make the call. That is the only version of this that I would trust running on something I care about. If you are thinking about doing something similar, start with the summary layer, draw the line about what the model is not allowed to touch, and keep the decision logic dumb. The simple version works. Subscribe and follow along. Thanks for watching, and I will see you in the next one.